we are going to discuss about the sharing of charges by capacitor or conductor, you can say. Sharing of charge. Sharing of charge by charged conductor. And due to this sharing, there will be a loss of energy. We are going to find that loss of energy. Let us take two charged conductor. One is this, another is this, with capacitance C1 and C2. And this capacitance is charged with charge Q1, and this conductor is charged with charge Q2. Therefore, V1 will be equal to Q1 by C1, that is potential of this conductor will be V1, and potential of this conductor will be equal to V2 equals to Q2 by C2, or we can say Q1 is equal to C1 V1 and Q2 is equal to C2 V2, right? And potential energy of this conductor, initial potential energy of this conductor is equal to half C1 V1 square, and initial potential energy of this conductor is half C2 V2 square. Also we can say that total potential energy U1 or total potential energy U, let us say U before the connection is half C1 V1 square plus half C2 V2 square, and total charge of the system of these two conductor is Q1 plus Q2. Now these conductors are connected by a metallic wire. Let us connect these two conductors by a metallic wire. If the potential of this conductor V1 is greater than the potential of this conductor, let us say you can consider V2 also greater than V1, you may consider, but we are considering, or I am taking that V1 is greater than V2. Then what happens? Then there will be a redistribution of charges. That means since this conductor is in higher potential than this conductor, since this conductor has the potential V1 and this conductor has the potential V2, so, and we also assume that V1 is greater than V2, so you can, or we can say what happens? There will be a charge transfer from higher potential to lower potential. Charge transfer of positive charge. There will be positive charge transfer from this conductor to this conductor. This flow of charge continues till the potential of both the conductor will same, or that means charge will flow from this conductor to this conductor. Due to this flow of charge, the potential of this conductor decreases and potential of this conductor increases. Finally, when the potential of the both conductor is same, equal, then this flow of charge stops. Here, let us say this equal common potential is V. V is the equal common potential. It is also called the common potential of the conductor. Let us say V is the common potential. Now, what will be the charge of this conductor after sharing of charges? This sharing of charges completes when the potential of both the conductor has the same value, and this same common potential is V. Now we can say there is an equilibrium here. Now the charge on this conductor equal to C1 into V, and charge on this conductor will be equal to C2 into V. Is it clear? The charge on this conductor will be C1 into V. C1 doesn't change, C2 doesn't change, because conductor is same, environment is same. So capacitance of both the conductor remains the same. Therefore, from the, we know, since no charge comes from surroundings or no charge go outside these two systems, then according to charge conservation we can say the total charge before redistribution or before sharing will be equal to the total charge after sharing, or we may say C1V plus C2V, Q1 is equal to C1V, Q2 is equal to C2V, or we may say C1 plus C2 into V. Therefore, the common potential V is equal to Q1 plus Q2 divided by C1 plus C2. Or you may write this as Q1 is equal to C1 V1, Q2 is equal to C2 V2. Therefore, C1 V1 plus C2 V2 divided by C1 plus C2 will be the common potential of both the conductor. Therefore, the charge on conductor this, that is conductor, you can name the both conductor. This is conductor A, this is conductor B. Conductor A, conductor B. Therefore, charge on conductor A is equal to C1 into V, that is C1 into Q1 plus Q2 divided by C1 plus C2, and charge on conductor B after the sharing, you can say this as C2V is equal to C2 into Q1 plus Q2 divided by C1 plus C2. That means Q1 by Q2 is equal to C1 by C2. That means sharing will be such that the conductor with greater capacitance store greater charge or have the greater charge, and the conductor with lower capacitance possess less amount of charge. Distribution is C1 by C2. That is, the conductor with greater capacitance possess large amount of charge, and conductor with lesser capacitance possess less amount of charge. The potential energy of conductor A after sharing of charges is half C1 V square, and potential energy of the conductor B after sharing of charge is half C2 V square. Therefore, total potential energy of the system of two conductor is U dash equals to half C1 V square plus half C2 V square. From here you can write half C1 plus C2 into V square. Is it clear? Now, let us verify that either these two are same, or this is greater than this, or this greater than this. Let us verify that. We are going to find U minus U dash. This is U and that is U dash. U equals to half C1 V1 square plus half C2 V2 square, and U dash equals to half C1 plus C2 into V square. Or we can write half C1 V1 square plus half C2 V2 square minus half C1 plus C2 into V is what? V is this, C1 V1 plus C2 V2 divided by C1 plus C2. C1 V1 plus C2 V2 divided by C1 plus C2 and whole square. Or from here you can write half. You can take this as common. Then C1 V1 square plus C2 V2 square minus, here is 1 C1 plus C2 and here is C1 plus C2 square. Then 1 C1 plus C2 will cancel out. That means you can write C1 plus C2, C1 V1 plus C2 V2 whole square divided by C1 plus C2. You can write U minus U dash is equal to half here, and C1 plus C2 is the denominator or LCM. C1 plus C2. Therefore, you have to multiply this C1 plus C2 with both this and this, and multiplying that we get C1 square V1 square plus C1 C2 V2 square plus C1 C2 V1 square plus C2 square V2 square, right? And here minus, and if we expand this C1 V1 plus C2 V2 whole square, considering the minus charge, we get C1 square V1 square minus 2 C1 C2, or you can write 2 C1 V1 C2 V2 minus C2 square V2 square. Now from here you see C1 square V1 square plus and minus, C2 square V2 square plus C2 square V2 square minus, that means these two are cancelled out. And from this we can take C1 C2 as common. That means C1 C2 into V1 square plus V2 square minus 2 V1 divided by C1 plus C. That means we can write half C1 C2, and this will be equal to V1 minus V2 whole square divided by C1 plus C. Now we know that capacitance of a conductor is a positive quantity, scalar quantity, positive scalar quantity. So C1, C2, C1 plus C2 all are positive, and this V1 minus V2 is also positive. V1 minus V2 whole square is also positive, whether V1 is greater than V2 or V2 is greater than V1. V1 minus V2 is always positive quantity. That means this U minus U dash is always a positive quantity, whether V1 is greater than V2 or V2 is greater than V1, which means U is always greater than U dash. U is always greater than U dash. That means the total electric potential energy of the two conductors before sharing of charges is greater than the total potential energy of the conductors after sharing of charges. U is greater than U dash, or we can say U dash is less than U, which means that there is some loss of energy. There is some loss of energy during the sharing process, or when two charged capacitor or conductor, rather we have discussed by the conductor. Since conductor is in capacitor, then you can say the capacitor also. There is some loss of energy when two charged conductors are connected together. This loss of energy appears to heat energy. During this process, this metallic wire will be heated, and also maybe in this process you may get some light. That means during this, or due to this sharing of charge, since energy is losses some energy, that means this energy where is gone. This energy is transformed to heat energy, to light energy, to sound energy. That means this loss of energy, this is the loss of energy. This energy is converted into heat, light and sound. When these two are connected, there will be a sparking. Sparking means there is a sound, there is a light, there is heat.